My name is Lyndon Kelly. I work for Michigan State University and Purdue Extension, 50-50 split. Tremendous opportunity for me. Been doing that for 12 years. I've been 32, almost 33 years this October with MSU. We're going to talk about some efficiency measures that have been going on in this state for over 40 years now. But first, I need to say, hey, this is a discussion of resiliency. I have the opportunity to work in 2 states with farmers that over the last 35 years have installed irrigation. So that's 540,000 irrigated acres in Indiana, 670,000 irrigated acres in Michigan. These are all, irrigation's not cheap. Some of you know that. These are all investments made by producers to be more resilient, to take care of the major issue of drought, lack of water. And what that's done is it's brought that investment, has made it so they need to look at higher value crops like potatoes, high investment crops. I look at some of just the insecticide bill for potatoes is higher than the whole bill for other people. So all of a sudden you got a lot on the table. Taking out the risk of no water is essential. You see very few potatoes raised dry land. That said, we raise most of those irrigated acres are on sandy loam soils that are extremely well drained. Now that does is 2 things. It makes it so I can get in the field when I want, and I don't have less risk of drowning out a crop. So that makes the potatoes and the seed corn, where you're in there multiple times in a year working through the crop, much more easy because of that well-drained soils. But also those well-drained soils have it so that we have very little runoff, and most of the water that isn't used by the crop that year in the season or outside the season between crops in the fall and winter goes to recharge, and these tend to have very good aquifers, especially where we build irrigation. We don't build irrigation where we don't have good water supplies to feed the system. So there is a lot of scrutiny because over the last decade or more, we started talking about climate change, global warming, all kinds of different terms. And if you talk about irrigation, if you punch it into Google, they'll talk to you about how they're running out of water in the West, the arid West. Okay? We don't live in the arid West. The arid West has very, very dry conditions, so you lose a lot more water for the crop. Our ETs today are right around 2/10 of an inch. In other words, an inch of water will last about 5 days. Out there, an inch of water is going to last more like 3 in the same temperatures, okay? Just because a lot more arid, a lot more evaporation that happens. But that scrutiny comes from people saying, well, maybe we're going to run out of water. We all want water. We all want to be able to hang on to our water and know that we're going to have it for us and our grandkids. So there's this push to look for more efficiency. So Youngsuck is working on irrigation scheduling. For over 30 years, we've had a checkbook irrigation scheduling system where the deposits are rainfall and irrigation. And the withdrawals are crop water use on a daily basis. Okay, so, and we look at the checkbook scheduling. And then since then, he's looked at these technologies about using soil moisture monitoring and giving that information to the producer on a as needed basis, right on your phone, to make those decisions. I'm working on some of the background things that we could look at making irrigation more efficient. One of those things is, how do we get the application to be uniform? Because in general, if we have a low application area in the field, producers will tend to water to keep that area up. Okay, so in other words, you'll hear guys say, well, the droughtiest part of that field is the southeast corner on the second ridge. If that starts to roll, I haven't used enough water. Okay, what if that reason that droughty corner exists is because it's in one of these drips? Okay, this is a map of the machine running at the pressure it should be. This is the measurement from a Taco Bell cup placed every 10 feet from the center pivot point all the way out to the furthest reach of the end gun. Okay, in a perfect world, every one of those Taco Bell cups would have the same amount of water. So if I set it at an inch, it should have 180 milliliters of water, because that's a 1 inch rainfall on a Taco Bell cup is about 180 milliliters of water. Our engineering would get it down to plus or minus about 10%. So I'm going to go about 162 to almost just shy of 200. That's in the engineering that's out there. If there's mistakes, I could be far under that or far below that. And if you look at it here, at the pressure it should be at, we have some places getting 30 and the rest of it getting in the 40 range, okay? About a quarter short. So we'd want to fix that one. But we get out here to the end gun area, past the fourth tower, and we got a big area that's way over watered, almost double. And then we look at it, and it's only getting 70 feet. And the irrigators in the room, they say, man, my end gun's only getting me an effective 70 feet. Something isn't quite right. I probably ought to be talking to the dealer about trying to get a little better coverage. Unfortunately, if we could take this water that's over applying here and moving it out 50 feet, we'd probably have enough water. We just got to make it more even. Okay? So that's a discussion. Very few of you are going to go out and put the 10 Taco Bell cup every 10 feet. Okay? You got to have a student helper to do that. He's done what, 3 this year? Okay. So that's how we get them done. But the rest of you are going to say, well, how do I get the improvement or some of the improvement or most of the improvement without doing that work? Well, we went through and said, okay, what are the major areas of the last 40 machines we've checked, 43 now if we enter those into the database, and what improvements as far as volume of water over acres would have us the best improvement, the best impact. Straightening out the end guns and the interface between the sprinkler package and the end guns, #1, okay? And that's just a matter of keep working on it. Get yourself 10 Taco Bell cups and keep adjusting until the same amount of water is in all 10 cups as you pass over them, okay? It's not fun. Once you get it there, it's usually done for the life of that piece of equipment, that end gun that's there, unless you bang it into the trees or something else. Those things happen too. Second most common correction that can be made to save volumes of water over acreage is feeding the supply that's required for the sprinkler package. So a lot of you, when you put your system up, or if you put a new system up, or you bring a used one in, you call the dealer and you say, order me a sprinkler package. I want the newest nozzles, I want those regulators on there because the field's got some hills to it, and he'll say, how many gallons per minute do you have? If you're a smart guy, you'll say, I tested it, well driller came out, my well's putting out 700 gallons at that point. Okay? If you're in a hurry, you say that well's been running at 700 gallons. Okay? What if it's only at 600? Well, if it's only at 600, you don't have the volume you think you do, and that's where we see this down here. And of course, that lower volume equals a lower pressure, and that difference shows up at the far end of the machine. Now that's a problem. What portion of your machine does most of the work? The far end of the machine, by far. That's that. I started out 8th grade geometry, was my first out of college, teaching 8th grade geometry. The far end of the circle is the biggest. Think about a big bow and arrow target. How many acres are under each of those rings that are out there? As you get further out, you get a lot more impact. So if we have too little water, the impact's at the far end. How do we make sure we got the right amount of water while we do some testing? Over here, as you came in, there's actually a flow meter running. It would be running if we had the battery power to it, and it would be checking the amount of flow that's going through. That's a service that many of our dealers offer. Some loan you the equipment. A lot of times it's a piece of pipe with a impeller meter in it. The important thing is that thing gets checked every year to make sure it's calibrated. Be aware of the permanently installed impeller meters that have not been checked. Okay? When we do research projects and during the winter, I'll say, hey, we've got this study coming up and we're looking at early planted soybeans versus late planted soybeans and the peak water use. And I need 25 acre or bigger parcel under center pivot irrigation. Be nice if it had a good flow and good things. I go out there, get the flow meter, and the flow meter reads 300, and the sprinkler package says it's supposed to be 500. Which do you believe? Well, I go recalibrate the flow meter. How do I recalibrate the flow meter? I borrow one of these things from either my local dealer, or this one came from Ag Engineering, and I check it once a year. Maybe don't invest in the permanent one and invest in having your equipment checked at least every other year to make sure we got the flows that are coming into that's there. Now, that said, Very few of you are going to do that. Okay? I work in an industry, when you look at the Ag Census from 2017 and the Farm and Ranch Irrigation Survey, in Michigan, more of you answered that your irrigation scheduling method was to turn your system on when your neighbor turned it on, no kidding, than any scientific-based method. Okay, so you got to be thinking about what that means as far as where we're at. We've got either people don't take the irrigation, the surveys very serious, or we got a lot of work to do. So that's out there. So we're looking for a quicker method. Almost every center pivot that goes out there, every system has a pressure gauge, okay? And that pressure gauge indicates to you somewhat the flow. If the flow is on correct, then you'll be at the settings that are there. Can we pass out these? What's left of these? So handouts coming around from Young Suck here. And it has our names and addresses and phone numbers. Mine's written really dark in one of the slides. That's so you only call me if you really want to talk to me. You'll find that, okay? So, but that said, that sprinkler, that pressure gauge helps tell you whether you're on track. So if you look at the PowerPoint slides there that are on that sheet, this pivot was supposed to be at 37 pounds of pressure. That's the center line. If the pressure gauge is there, it would be at 37 pounds. If it's below that, more than 10%, then we ought to be thinking about it, okay? Now, if it's below that, is this a chronic problem or is it something that we just did recently, okay? How do I know that? Well, if you have whoever's starting the machine each time, if they wait 10 minutes, get the pressure of the machine with the end gun on and with the end gun off, and write it down, okay? Now, all of a sudden, I can send an employee out and say, hey, stay 10-15 minutes, cool off in the truck, look at the pressure gauges, turn it, if you get the reading with it on, then turn the end gun on for a minute or off for a minute or two and get a reading with it off. My readings should stay in the same ballpark as the other things. Now, last but not least, last thing I'm going to cover, what if the reading is down drastically? What if I've been getting 37 pounds all summer? To send the employee out, he calls me and says, hey, I've been here a half an hour, I've listened to the radio, at least 2 news programs already, and this thing is not getting up to 37 pounds. What could be causing that? What would cause that? Pump
failure or
pump,
just
okay.
blow
Pump failure. Okay, so it could be the pump. It could be if he's got running a diesel pump, he doesn't have it up to the right RPMs. It could be electrical problems, hopefully that you're kicking out if you're low voltage. What else could it be?
Nozzles are starting to wear.
Nozzles are weird. That would be a long-term decline because our nozzles wear out in a period of years. So all of a sudden I'd have 35, and then next year all I can get is 34, and then the next year 36. Anything else? What if it was at 37 yesterday when we started, and today we go out and start it and it's only in the 20s?
Suction's probably screwed up.
I could be sucking in too many frogs and toads and tadpoles and screwed up the screen. So I'm spending more of my energy sucking it in. Very good, so you clean the screen. Anything else? How about
Leaks.
leaks? I've got a hole somewhere, okay? So you start saying, hey, look for the hole. There's one more obvious one. A lot of systems are running more than one distribution system. Maybe we're running some stationary guns in the corner, or we're running 2 pivots from that. Maybe they're both running, okay? Those are all issues that are out there. Those are issues that you can help determine by looking at the pressure gauge and keep. Never run it when it's going the other way because you can't get anywhere. You can't get it near the coverage. Yeah, but you do it when it's calm and then hope that it averages out. Any other questions? Yeah.
And what about with the irrigation scheduling? I know it's nice to say, oh, I should water now, but have you done any work on the, I guess, system approach of it? You know, it's great to say this field needs water today, but you have to take into account what else needs water as well.
So when you talk about like our resources, a lot of times a pivot, it'll be 1 or 2 pivots coming off of a supply, okay? So one of the first things we talk about is, do you have enough supply? Do you have 5 gallons per minute per acre that's out there? That's an inch every 4 days, okay? If you don't have that, then you start thinking about, well, can I get 2 different crops so that I have a different peak use? or what crop am I going to sacrifice if I have a 2012 year when I can't keep up with all of it. So, yeah, and there's a lot to it. We Young Suck system is based on the concept that you at the turn-on point you make the decision, and then the rest of it's 3 days later. But last time you made the decision at the turn-on point, and hopefully it's 3 days later.